By the end of this video, you'll be able to control your spindle from the Durapulse GS20 Drive keypad. You'll be able to start the spindle, adjust the spindle speed, reverse the spindle, and stop the spindle. You'll also be able to view the spindle's RPMs on the drive's display, and you'll have added a switch that tells the drive to accept commands locally from the keypad or remotely from the CNC. Once this is done, you'll be ready to connect the Altmill CNC to the drive via RS-45 or PWM. This is everything you need to do to get a Durapulse GS20 Series drive to control the spindle from the drive's keypad and add the keypad or CNC selector switch. If you're already familiar with this stuff and just need the answers, take a screenshot of all of these steps and a screenshot of this schematic. Stop the video and go have fun. These 2 pages contain everything we'll be discussing in this video. Now if you need to see exactly how to do all of this, well, stick around, because we're going to walk through each of these steps in this video in the order shown. And I'll share some insights and tips along the way. Timestamps to each item in this list are included in the video's description if you just want to jump directly to a single topic. Here we go. The terms drive, VFD, variable frequency drive, and inverter all mean the same thing, and we'll be using them interchangeably in this video. All you need for this video is a drive and a spindle. Your CNC doesn't even have to be built yet. I'm using this Durapulse GS20 drive from Automation Direct simply because that's the one I happen to have on hand. It's the NEMA 4X version of the GS20, but everything in this video applies to all GS20 series drives. NEMA 4X means this drive is resistant to dust, water, and corrosion, which makes it perfect for the dusty environments created by CNCs. The GS20 series of VFDs are modern, feature-rich drives with lots of extras you won't find on your typical inexpensive hobbyist VFD. Things like built-in RFI filter, safe torque off, remote keypads, a built-in PLC, constant torque mode, and dynamic braking, just to name a few. It even has free drive configuration software that makes setting up, changing, and backing up drive parameters super easy. And it includes an O-scope option so you can see what's going on inside the drive while it's running. I like Automation Direct because they have free 2-day shipping for orders over $49. Their support is free and based right here in the US, and all of their documentation, manuals, and 2D CAD drawings are all free. They also have 3D models of all their drives that you can download and use for free. Now, before setting the drive's parameters, there's a couple things you need to do to prepare the drive. First, we need to remove the RFI jumper. The GS20 drives come with an RFI filter built in, one of those extra features this drive has. But it only works on 3-phase symmetrical power lines. I'm using a single-phase 220, which is not a balanced 3-phase supply, so we have to remove that jumper. Different GS20 drives have it in different places. This one's right here, so I'll loosen that screw, the jumper falls out of the way, and tighten it back down. The non-NEMA 4X drives tend to have it on the side, like over here. You'll loosen a screw inside here, and then pull the jumper out. Read the drive's manual to see if your drive has one of these and how to remove it. If you forgot to remove the RFI jumper and hit the RFI filter with an unbalanced supply, well, it'll just damage the RF filter. The drive will still function, but you may smell a little smoke for a while from that RFI filter that you weren't using anyway. I'm assuming everyone knows how to wire power to a drive, but just in case, you simply wire the single-phase 220 VAC to the terminals like this. The second thing we need to do is condition the drive's capacitors. I think this is the #1 reason VFDs die prematurely. If a drive sits for a long period of time without being powered up, the dielectric layer and the large capacitors in a drive degrade. Then, when you apply the load with the high current demand, the oxide layer shorts out the capacitors and destroys or at least severely reduces the life of those capacitors and the drive. So read your drive's manual and find out how to reform or condition its capacitors. Every manufacturer does it differently. The Durapulse GS20 drive is easy. The manual says if the drive's been sitting for more than a year, just disconnect the load and apply power to the drive for 2 hours. Conditioning or reforming the capacitors is so easy, and it massively extends the service life of your drive, so please don't skip this capacitor conditioning step. I left this drive powered up overnight, so we're good to go. Finally, I'm going to do a factory reset on the drive so you know exactly where I'm starting from. On this drive, you simply hit Enter to select the parameter group. We need group 0, and hit Enter. We need parameter 2, Enter, and according to the manual, we need to set that to a 10 to do a full factory reset for the 60 Hz line voltage. If you're using a 50 Hz system, you would want to set that to a 9. There's lots of other things you can reset, but look at this. This drive actually has a built-in PLC you can reset separately. Yeah, a real PLC that you can program to monitor and control the drive and anything else you want. How about that? And Automation Direct provides the PLC programming software for free. Here are some videos to show you how to do that, and I'll put a link to the free software in the description below. Hit Enter to accept and reset the drive. To wire the spindle to the drive, just connect the 3 motor wires to these terminals. Don't worry about which wire goes where. Once we get things running, if the motor spins backwards, then we'll just swap any 2 of these wires to reverse the motor direction. The motor ground wire goes here, and the cable shield goes here. Now this is important. The shield gets connected to the chassis ground at both the motor and the drive ends. That's different from communication cables where you only want to connect one end of the cable shield to chassis ground. I'm using this flexible wire from Automation Direct, which is actually intended for servos because that's what I happen to have on hand. And I think the orange looks cool. Here are some other options if you prefer VFD specific cables. I like getting wire from Automation Direct because they'll cut the wire to any length you want with no upcharge, and they have free 2-day shipping for orders over $49. I love that I don't have to buy a whole spool of wire for a small job like this. Regardless where you get it from, make sure you get a cable that's designed for continuous flexing and specifically designed for VFDs or servos. Okay, let's configure the drive. First, let's configure the spindle-related parameters. Parameter 1.01 is the frequency shown on the faceplate of the motor. In our case, that's 400 Hz, so I'll scroll up to 400 Hz and hit Enter to accept. Parameter 1.0 is the frequency that all the input commands are scaled to. We'll just set it to 400 Hz so we get no scaling. Parameter 1.12 sets how fast the VFD should try to accelerate the spindle. I'll set that to 2 seconds. I don't like waiting. Enter to accept. Parameter 1.13 tells the drive how fast to decelerate the motor. I'm going to set that to 1 second, which I know is impossible under normal conditions, but I'm going to use that to introduce braking at the end of this video, where we'll learn how to quickly stop a spindle. Parameter 5.01 is the motor's rated amps. Looks like ours is 8 amps, so I'll enter that and hit Enter to accept. Parameter 5.02 is the rated power. Ours says it's 2.2 kilowatts, so we enter that and accept it. Parameter 5.03 is the rated speed. Ours is a 24,000 RPM, so I'll scroll up to 24,000 RPM and hit Enter to accept that. Parameter 5.04 is the number of poles. Now, because we entered the motor frequency and RPMs, the GS20 calculates the number of poles for us. Some industrial motors give you the frequency and poles. If you enter those, the GS20 will calculate the max RPM. So there's nothing for us to do here. I just wanted you to be aware that if you have a spindle that gives you poles instead of max RPM, you would enter that here in parameter 5.04, and the GS20 will calculate the max RPM for you. Well, that should be enough to get the motor running. The F display tells us what frequency the spindle will accelerate to once we hit run. Let's change that to 200 Hz, which is half our 400 Hz max. So the spindle should go to half of its 24,000 RPM max, or 12,000 RPM. Press the menu button to view the current frequency, which is 0 because we're not running. Hit run, and now the drive is sending 200 Hz to the spindle. If I bring up my tachometer, yep, the spindle's basically at 12,000 RPM. Hit the menu button a couple more times, and we see we're rotating in the forward direction. Down arrow to reverse the direction. You can repeat that several times to verify the spindle is rotating in the correct direction. If it isn't, then swap any two of the spindle wires to reverse the direction. And press stop to stop the spindle. We now have a fully functioning spindle that we can control locally from the drive's keypad. Now we need to connect a switch to a digital input so we can tell the drive to accept commands from the remote CNC instead of the local keypad. To do that, we're going to add a switch to input terminal 3 to tell the drive when we want to operate it locally or remotely. The digital inputs on this drive are pulled high, so we just need to switch them low to a digital common. Now we go to the digital input parameters and tell the drive what we did. Parameter 2.03 tells the drive what we want to use digital input 3 for. And that says to see digital input 1 for a list of possible values. So we pull up digital 1's table, and we see that to assign any digital input to be a local remote control, we need to enter a 56. We want digital input 3 to control local remote, so we enter a 56 for parameter 2.03. If we switch to the remote CNC control, we can still control the drive from the keypad because the default for remote is the keypad. We'll change that to RS45 or analog depending on which control method we choose in the next video. Now that we know the drive can control the spindle, we need to set up the CNC to remotely control the drive. You can use Modbus RTU over RS45 or PWM. I want to strongly encourage you to use the RS45 method. It's the most robust and accurate way to control the drive. Yes, it takes a little more effort on your part to get it set up, but the video shows you step by step exactly how to do it. Before you do that though, wouldn't it be cool if we could see the spindle speed on the drive's display in RPM instead of the 0 to 400 Hz frequency? Well, guess what? We can. If we press the menu button, we can cycle through the various displays. F is the frequency the drive will send to the spindle when we hit run. That's the one we adjust to change the speed of the spindle. H is the current frequency, which is 0 right now because we haven't hit run yet. And U is the user-defined field. Parameter 0.4 allows us to change that to dozens of different things, one of which is RPM. This says the display will show us a little R when we're viewing it to remind us we're looking at RPM. So I'll set parameter 0.4 to a 7 and hit enter to accept. Hit menu a few times to get back to the main screen where we see the little R telling us we're looking at RPMs. If I hit run, the drive tells us we're running at almost 12,000 RPM. Well, sort of. You see that little dot? That's telling us there are more digits off screen. So you kind of have to use your imagination a little bit when reading this RPM value, which explains why this is 12,000 RPM and not 1200. If I go to 100 Hz, that should be 6,000 RPM, and sure enough it is. And we don't see the red dot, so we know we are looking at the whole number. You can also tell the drive to default to the RPM display on power-up by setting parameter 0.3 to a 2. So now, when you send a command to run at 7,500 RPM, you can just glance over at the drive to quickly verify it's doing what you told it to. Perfect. Okay, we now have a drive that can control the spindle locally from its keypad, we can view the RPMs on the drive's display, and we have a switch that will tell the drive to accept commands remotely from the CNC. Now we just need to configure the CNC and the drive to work together. Pick the method you want to use, go watch that video, and you'll be up and running in no time.